Okay, hello everyone, I'm Salar and this is a tutorial for writing and real-time operating system. This is part 6 from this tutorial, and in the last part we completed the brief introduction about Linux operating system and writing some command in terminal. And in this part we are going to spend our time on programming and some other prerequisites and tools and environment that we will need for writing and real-time operating system. You may ask why we spend our time for prerequisites like operating Linux operating system or programming this much, because when you want to write a critical program like operating system and the system programs, you need a lot of information and deep knowledge about tools and environment. You can write an, for example, accounting program without this knowledge, but when you want to develop an operating system, you will need. Okay. You may have seen some environment and some software for programming. For example, in Windows like Visual Studio, or in other operating systems, Linux, Mac, and Windows, Code Creator. For writing an application for Android, for example, Android Studio, or for example, for microcontroller programming, STM32 Cube ID, that's based on Eclipse, for example. STM32 Cube ID. It's an ID. It's an integrated development environment. That it's a GUI program that you can write your program, creating project, configure project, and a lot of other things. You may have work with Kale for writing your program, and you're writing your code for our microcontrollers and other things. And this is for example, STM32 Cube IDE. It's IDE. You can create a new project. You can, for example, in project and properties, you can do some config for your project. You can debug your project in a GUI program. I know that IDE makes or works and or programming so much easier, and let's me to close that. But we can do all of your works in terminal. Okay, in terminal by typing some commands. For example, we could create a new folder in GUI, and we can create a new folder or directory in terminal. Creating, for example, a new folder in GUI is easier than terminal, but terminal give you more access and more configuration possibilities. And why we want to program and do our works in terminal instead of IDEs. IDEs is more easier, but we want to do our project in terminal. Why we do our projects in terminal? Because when you want to develop, for example, an operating system, you need deep knowledge about compile process. For example, how a code will compile, how a code or object program will link with other object programs and other parts of codes. And when you want to compile in terminal by subcommands, you have a lot of options for commands. Okay, what options? For example, ls-l is option. And when you compile your programs in terminal, you have a lot of options. Okay, and you have a lot of control on your process, on your compiling, and it gives you a lot of access and control on your code. Okay, I know writing code or compiling our code in terminal is harder, but it gives us better observation on compile process, and you need to do some of your works in terminal. As you can see, for example, Linux operating system now compile in terminal, and you uh, not you can't, but you may cannot to compile, for example, a Linux operating system in an IDE. Okay, when you want to compile or writing kernel program for example, Linux operating system, you do all of your works in terminal. Okay, and many of big softwares like operating systems and compilers compile in terminal mode. Okay, so in this tutorial we spend a lot of our times on terminal for programming and compiling and linking our programs and even debugging our programs. Okay, but I will give you some information about IDEs and how can I configure an IDE for programming. Okay, so what's a compiler? Compiler is a program that convert your source code to an executable file. Okay, for example, you write a program, for example, in C or C++, and compiler is a software and the tools that convert your program to an executable file that can execute and you can execute your program, okay, after compiling. Okay, now what's the compiler that we will use and we want to use for our works? It's GCC, compiler collection, and it's created by Richard Stallman. So you can have, for example, macOS laptop or desktop that you, for example, can have Clang. Clang is another compiler that it's based on LLVM project, and you can study about Clang or GCC and their advantages and disadvantages and on internet. Okay, but we will use from GCC. For example, you can have Microsoft Visual Studio compiler. Okay, Microsoft Visual Studio is a command line compiler that you can use that for writing your code and compiling that in Windows. Okay, it's another compiler, but we will use GCC. GCC is an open platform compiler. What's open platform compiler? For example, assume that you want to write a code for a compiler for a computer that its processor is Intel, okay, and its operating system is Windows. You can use GCC. Or for example, you have a Raspberry Pi, okay, Raspberry Pi board, and you want to write a program and compile it for Raspberry Pi, and the architecture of Raspberry Pi processor is ARM. You can use GCC. GCC is an open platform project and compiler collection and other tools, for example, debugger that you can use it in a lot of platform, even in MCU. Okay, for example, I have an ARM GCC. It's for programming on ARM processor. Okay, and we will use from this compiler for compiling our code for MCUs and microcontrollers. Okay, so GCC is a big project and it's an open platform compiler. You can use GCC in Windows, but using GCC in Linux is better, and you will have better experience when you use GCC in Linux terminal. Okay, but you can use GCC in Windows terminals, and you can use GCC in Mac OS terminals. Very good, like Linux, because Mac OS and Linux are Unix-based operating systems. So now the tools and command in is GCC. So how can I compile, for example, a file like solar.c with GCC? Where we are in home directory and home user directory. Let's do create a directory, name is test and cv to test pwd, I mean test solar. And let's do create solar.c file. Okay, let's do write an hello world program in C. If I press enter and write hello, where is the program in C? stdio.h main and okay, printf, sorry, for example, in that whole and a new line. Okay, Control X and press Y for saving. And now I have a C file and it's here. So how can I compile that? With GCC. It's so easy. Just GCC and name of file and press enter. Now I have an output file. Okay, the name is a.out. If I press L/L, I can see a.out, an executable file. Okay, X in permissions, executable file. We said that an executable file in Linux is a file that it has executable permission. Okay, so it's a simple file. It's not executable, but a.out is an executable file. So how can I run an executable file in Linux? The process and command is so easy. / and name of file. Okay, we write / and name of file for running an executable file in Linux. And if I press enter, sorry, the name of file is a.out. Okay, a.out, and if I press enter, hello world. Okay, I run my code with / and name of file, hello world. Okay, so what's the name of file? a.out. So how can I set a specific name for my output file? It's so easy. By an option in GCC name of file that I want to compile -o after that name. Okay, for example, in here output. Okay, -name after that name of file. -o and name of file should be continuously, and for example you can't write -o here. Okay, you should just write it just before name of your file. You can have an space or you can have no space between -o and your name, but it's more beautiful. Okay, and if I press enter and ls, I have an output file. Okay, it's not important for your file extension in Linux. For example, you can set an .exe for that. Extension in Linux are not important because executable file in Linux is a file that it has executable permission. Okay, so extension is not important. I can, for example, set an .exe extension or suffix for that. And if I run my output, it's hello world. And I can run output.exe and it returns hello world terminal. Okay, so let's do remove output.exe and a.out.exe. rm output.exe and a.out. Okay, now I have my file and my output, my executable file from Solar. So how can I add a header file to my project? Let's do create, for example, a header file. Nano, for example, here solar.h. Okay, open that and write my code in header file. For example, I shall include stdio.h and, for example, function. Okay, what's the name of function and body of function? For example, printf here. Oh, okay, Control X and press Y, press enter. And now let's do change my C code. Nano solar.c and add this header file for printing. For example, I want to print hello world just by print function. Okay, I have a print function in my solar.h header file. And how can I add header file? Now I should add it in quote mode. Okay, it's angle bracket mode and it's quote mode, and I will describe what's the difference between quote mode and angle bracket mode. Okay, now in quote mode I write solar.h. Okay, solar.h is a file that it implements print, and I can use that in my C code. Okay, Control X, press Y, enter. Now cat solar.h and cat solar.c. Okay, it uses a print file from solar.h and solar.h implement print. Okay, and if another time GCC solar.c-o to output, press enter. Now I have output file another time, and if I run output I have lower. Okay, when you want add and include solar.h in your .c file, where compiler will search for this file solar.h first in the working directory, the directory that solar.c is in that. Okay, solar.c is in that home and test directory. So first compiler search for solar.h in home and test directory. Okay, first in that. So now for example, let's to create mkdir and header. Okay, header. Now I have header directory in my test directory, and I want to move solar.h to header. Okay, now I don't have solar.h in test directory. Okay, and I have it in header. And if I run compiler another time, and another time, it says that solar.h not found. Okay, solar.h not found because it's not in test directory. So how can I say to compiler that search for header file in header directory? Okay, what's the option? Okay, what's the option? This option is just for coated mode. As you can see, solar.c, I include my header file in coated mode, not angle bracket mode. Okay, angle bracket mode is here, right here. Okay, in coated mode. I just talking about coated mode. If I want to add header to those directories that compiler search that for coated includes, I should write this option GCC -I code. Okay, as the name implies, it's add and include directory for coated includes, like this coated, not for angle bracket includes. And name of directory, I can write complete name okay, it's complete name of directory, but I can just write it relatively because I run GCC in that test directory, and it can search and find header directory in test. Okay, I can just write it relatively. Okay, like this. Name of file -o output. Okay, and another time if I press enter, okay, it can find header file, my header file solar.h in header directory. Okay, because I add header in searching path for coated header files. Okay, another time if I run output, lower. So where compiler does it search for a coated include file? Let's do describe it with more detail here. Okay, when you add your file in coated mode, okay, coated mode, not with angle bracket. Okay, not with angle bracket. In coated mode, search first in current directory that you run your GCC command. After that, in those directories that specified by -I code option. After that, in standard system directories. So first in current directory, after in coated directory, after that in a standard system. So if I, for example, create another, for example, let's do another solar.h file in current directory, solar.h, and in that I will talk about angle bracket including, but I now talking about coated mode. Okay, stdio, that's h. Another time if I write print file here, for example printf, and here I think hello from current. Okay, hello from, let's do like current. Okay, now I have a header file that it implements print in current directory and another in header directory. Okay, and in current directory and another in header directory. So if I run my code GCC and without dash I code, okay, I can write that in dash code, okay, and let's let's do cd and GCC dash I code header salar dot c dash o, and if I run it, hello from current. Okay, if I open my directory test here, where is test here, I have a directory here, a header file here. Let's do close it. Hello from current in current directory, and in header just a hello world. Okay, but because compiler first check current directory, it takes salar.h from current directory. Okay, so it's the order: first current, after that search in iCodes directories, after that in standard systems. Okay, let's close here, minimize here, and we're here. Okay, let's open the salar.c and change it to angle brackets mode. Okay, change it to angle bracket mode. Control X, press Y for saving, accepting save, and another time GCC dash iCode header name of file dash o and name of output file. Okay, if I press enter, it says I can't find salar.h. So how compiler search for header file when you write your header file in angle bracket mode? Okay, in angle bracket mode. For example, stdio.h. Where is std.io? Let's do open it another time. When you write your code in angle bracket mode, it search just in standard system directories. So where is standard system directories? Let's minimize that and run my code with another option. That should be verbose mode. Okay, if I press enter, I have some useful information from compiling. What's most important part now with us is here. It says me the search path for including. It says that if you want to use quoted mode, search start here, and before that in current directory, but after that in header that is quoted. Okay, that's it. That's add with iQuote option. Okay, with iQuote option. After that in system directories. Where is my system directories? Here. For example, one of that is user lib GCC. Let's do open that. Move to file system. In user lib GCC. Where is GCC? GCC here 9 and include. Okay, there is some header file here. First in here, and after that in user local include and user include. For example, let's do search for stdio in user include. ls user include in, for example, ls dash l and grep it with std io.h. Okay, so I have std.h here in my system directories, system include directories. But I can do this. For example, let's do open an header file nano solar, for example, that h, and write it in quoted mode. Okay, let's see, wait. Another time run my GCC. Sorry. Before that, I should correct solar.h. Nano solar.c. Change it to quoted mode. Okay, change it to quoted mode. Control X, Y, Control N. Another time run my. Okay, it works. So as you can see in my header, let's do run my code. Hello from current cat solar.h. As you can see, I add stdio in quoted mode. Okay, when you write and include preprocessing in quoted mode, search in current directory, after in iQuote directories and system directories. Okay, so and if I run it another time in verbose mode, here it search for std.o in current directory, after in header, after in these directories, and it can find it here. Okay, and can find it here. So let's open it. So when you write your code in this mode, quoted mode, compiler search for that in current, after that in iQuote, after in a standard system. But it's better to write your standard header file in angle bracket mode because it can find it in standard directories. Okay, and it works another time, and it return me a lot of information in verbose mode. So when you write code mode current icode standard system in angle bracket mode, just search in standard directories. Okay, standard directories. Where is the standard directories? Here. So how can I add, for example, a header directory in a standard directory? Okay, I saw that when you write icode option after that name of your header file, you added header file, and I added header file in quoted directory. But if I write dash capital I in verbose mode, I add header directory in standard directories. Okay, here header is here. Before that, header was in quoted mode. By now header is standard. Okay, now let's do rm salar.h ls. Let's add header in a standard directory, and let's do cd header. Yes, okay, salar.h, and we can add header with dash capital I in a standard directory. pwd I'm in test file. Let's do salar.c and write it like here. Write it in angle brackets mode. Control X. Okay, cat salar.c. I want search for salar in angle bracket mode. So in angle bracket mode in a standard system, just in a standard system. So if I want add salar.h in a standard, I should add header in standard directories. Okay, another time salar.c-o in output. Okay, so what for angle bracket, I should add my directory in standard directories by dash capital I. It's here. And now another time run output. Lower. Let's do search for GCC options. If I search for example, GCC command line options, here is a lot of options. If I open option summary and search, for example, for dash I code. Okay, option for directory search. We have a lot of options, and you can study about them, but one of the most important is dash I. Okay, for adding a directory to standard system directories. Okay, another time, if I run my compile process in verbose mode and press enter, and now I have header in search path for angle brackets in standard directories. Okay, and start searching first in header, after here, okay, from up to down. Okay, today we saw that you can include your header files in quoted mode, and compiler search for it in current directory, after that in iQuote directories that you write in your compile commands, and after that in system directories. And you can write your code in angle bracket mode, and compiler search for that in standard system. There are some standard system that you can see them in -v, okay, with -v, okay, and I can add some other directory in my standard directories by -I, okay, and my directories, for example, directory 1, directory 2, and directory M. Okay, I can add more than one directory with -I, and I can add more than directory with that -I codes. Okay, so you can write all of your code in bracket mode, okay, in angle bracket mode, and just add your directory by -I, and it will work for all of your options and all of your directories. Okay, you can omit quoted mode and write all of your code in angle bracket mode. Okay, in angle bracket, and add your directories by -I. As you can see, if I, for example, cat solar.c, and another time cat in header solar.h, I write all of my code in angle bracket mode, and I can add my header directories with -I. You can do all of your works with -I and angle bracket mode and small comma, angle bracket mode with small comma. Okay, it was some about writing your code with GCC, and I said that we have some other compilers, for example, Clang. Okay, and if you don't have GCC, you can install it in your system just by this command. Okay, you can install GCC in your command, or for example other compilers, Clang. Okay, but I have it in my operating system. And when you install Mint 20, GCC is one of your pre-installed tools. Okay, so I have Clang in my computer, and I can run my code with Clang. Okay, another time, less, I have output, and I have lower. Okay, you can search for compatibility between Clang and GCC. Okay, in Compute. There is a lot of common options, and almost all of the options in GCC and Clang are identical. Okay, but there is some and a little difference between GCC and Clang options, and there is some difference between them. But we will use GCC in our works. Okay, if you don't have Clang or GCC, and if you don't have GCC, you can install it with sudo apt install and GCC. And if I run that, it's says 0 for upgrade, 0 for newly installed, and 0 for remove or upgrade. And it says that you have last version of GCC in your system, and I can see my version, and it's here, 9.3.0. It's my GCC version. Okay, enough for today, and I will talk about GCC and its option more in next parts. Thank you very much, and see you soon.